Hello viewers on YouTube. In this video tutorial, we are going to consider rotating mirror. You see, when we have a plane mirror such that a ray of light strikes that plane mirror, it's obvious that a reflected ray will be observed. Now, if this plane mirror now tends to be rotated at a certain angle, while the incident ray is kept fixed, then the reflected ray we tend to make an angle such that the angle of rotation of the reflected ray is now observed to be twice the angle of rotation of the mirror. But what am I saying in essence? Let's try to put this into visual illustration. So let's consider a plane mirror with a normal. A normal to a plane mirror, or plane mirror as its normal, is a perpendicular line that is at a right angle to this plane mirror. Now, if a ray of light strikes this plane mirror as an incident, let's assume is a light source coming from this region. So by the time it strikes the plane mirror, then a reflected ray will be observed, and that will be in the other direction. Perfect. Now, what we are seeing in essence is that what if we duplicate this mirror and then rotate its duplicate? So let's rotate its duplicate at a certain angle. So let me rotate that this way. Coming. Oops. So if you rotate it at a certain angle, okay, perfect, let that be enough. Okay. Now, notice that if this angle of rotation, the angle between the position of the mirror initially and the position of the mirror now, let that angle be theta. Notice that the position of the normal will also change. This won't be the normal for the current position of the mirror, because this yellow line is no more perpendicular to this mirror. So what will now be the next normal? So the normal will now be in this direction. So this is now the new normal. As you can clearly see that the green line is now completely perpendicular to this plane mirror at its current position. Perfect. Now, if we keep the incident ray or the source that produces the incident, if we keep it unchanged, if this line is still the incident ray that strikes this mirror at this current position, the position of the reflected ray will change, definitely, because the mirror has changed its position. So the new position of the reflected ray will now be the line in blue color. So that will be this way. And the reason is all because the glassing angle that has to be formed must be the same. Are we together? And aside that, the angle between the incident and the normal must be equals to the angle between the reflected and the normal. Perfect. So now the goal is to find the angle of rotation of the reflected ray. You know, initially, this is the reflected ray. Now the reflected ray has now rotated to this position. So we now want to find the angle of rotation of the reflected ray, which is this angle to say. So the goal is to find x. This is the value of x. How can we get x? Now, let's focus on this diagram. Earlier, we said the mirror is being rotated at an angle theta. Notice that if this is n1, or let's say n, the normal, let me use a color you can see properly. Let me use white. This is the normal. Now the new normal, let that be n prime. This is the reflected ray initially before it's being rotated, while this is the r prime, the new reflected ray when the mirror is rotated. The incident ray may remain unchanged. You understand? It remains unchanged. So initially, before the mirror is being rotated, the angle between the incident ray and the normal is I, which is the angle of incidence. The angle between the reflected ray and the normal is R, which is the angle of reflection. Now, what will be the angle between n and n prime? What do you think? This angle will be theta. The reason is all because as we are rotating that mirror, the normal too will be rotating along with it. That is why this normal tends not to be the normal for this mirror at this current position. That is why it changes, because it has to be perpendicular to, as you are moving it, it moves along with it. You can clearly see, if this mirror now, by the time it gets to this position, this normal would have been lying horizontally, still showing that they are perpendicular to themselves. Are we together? So this angle will still be theta, which will be the angle of rotation of the mirror. Perfect. Now, if this is theta, and we know that from here to here is r. Now, from the law of reflection, we know that the angle of incidence is always equal to the angle of reflection. So instead of r, let's have it to be I. We are still doing the same thing because they are equal in magnitude. So let this still be I. So if from here to here is I, then from here to here will be I minus theta. Are we together? So I've removed this angle from this entire angle to have this portion. Are we together? Perfect. Now, for the position of the current mirror, we say this is the angle of, this is the reflected ray, and this is the normal. So the angle of incidence this time around will be from here, let me use the green color, from here all the way to this point. That is now the angle of incidence. You can see that is M prime for the new position of the mirror, and this is I. And what will be that angle? This place is I, this place is theta. That will be I plus theta. So therefore, the new angle of incidence is I plus theta. Perfect. Now, what about the new angle of reflection? Earlier we said, according to the law of reflection, the angle of incidence is equal to the angle of reflection. Definitely, from the normal all the way to the position of the new reflected ray, that will still be equals to I plus theta. However, we have gotten from here to here to be I minus theta. Definitely, it will be very straightforward for us to get the value of x, which is simply from here to here. So now, subtracting this portion from this entire portion gives us the value of x. So definitely, x would be equals to I plus theta minus, in the bracket, I minus theta. And at the end of the day, we have I plus theta minus I plus theta. As the negative take effect, I cancels I, and we end up having the value of x to be 2 theta. And this brings up a conclusion and a postulate that if a mirror is rotated at a certain angle, then the reflected ray will be rotated twice the angle at which the mirror is being rotated. And that is what we want to keep in mind. Are we together? Perfect. Now, to apply this into good use, let's consider an example. Example number 1. A ray of light is directed at a plane mirror so that the angle of incidence is 35 degrees. If the mirror is then turned through an angle of 15 degrees about the axis at the right angle to the plane of the mirror, find the angle between the incident ray and the reflected ray. So let's begin by drawing a picture. So if we consider a plane mirror right now, so we will have a normal to the plane mirror. Oops. Okay, let's just work with that. Now they said a ray of light is directed at this plane mirror. So let this be the ray of light. Perfect. Now the incident angle of this ray of light is simply 35 degrees. And this will be the angle between the normal and the incident ray. So let this be I. Let this be the normal. Perfect. Now, if the mirror is then rotated at an angle of 15 degrees, let's find the angle of reflection first. This will be the reflected ray for this incident ray. And its angle also will be 35 degrees. Note, we won't have our angle to be drawn to scale because we are not measuring it, you understand? We are just using it, we are just using the visual illustration to show what we are trying to solve in exercise. Perfect. Now this mirror is now rotated at an angle of 15 degrees. So let's now assume this is the new position of the mirror. So the angle is 15 degrees. Perfect. So now we now have the position of the new normal. Let the new normal be somewhere around here. Now we know that this place will be 15 degrees as well. So definitely the new angle of incidence will be 35 plus 15. So that's simply 50. So now the new angle of incidence, which I will write as Ni, is now 50 degrees. Now the new reflected ray, let that be somewhere around there, because the incident ray will be kept fixed. Okay, the source will not change its position. So now the goal is to find the new angle of reflection. Earlier we said that the reflected ray will be rotated twice the angle at which the mirror is being rotated, which simply means this angle will simply be 2 times the angle of the mirror, that's 30, 2 times 15, that's 30. Perfect. So this is 30 degrees. Now within this angle, what will be this angle? Since from here to here is 35 and from here to here is 15. 35 minus 15, that gives us 20. So this is 20, then we add them together and we have 15. So the new angle of reflection R is now 50 degrees. So the angle between the incident and the reflected ray is now 50 plus 50, which is 100 degrees. So that's how to easily solve problems involving rotating mirror. So thanks for watching. If you haven't subscribed, feel free to subscribe. Thank you. See you in the next video. Bye for now.